Running a large language model inside a macOS virtual machine on Apple Silicon has always been slow because the guest GPU reports itself as an old, limited device. The Kua project just shipped a shim that changes that story, and it claims 11 to 16 times faster inference. Let me walk through what it actually does. Here it is, straight from the source. The first thing to be clear about: this is not real GPU passthrough, where the hardware is handed directly to the guest. It is a compatibility layer scoped to one process. When your app asks Metal what the GPU can do, the shim intercepts that query and answers with enhanced capabilities. The compute still flows over the paravirtualized GPU path that Apple already ships with the virtualization framework. No kernel changes. Under the hood, it edits just 2 reported values for the injected process. It claims Apple GPU Family 9 instead of Family 5, and it raises the maximum thread group memory from 32 kilobytes to 64. Those 2 lies are enough. llama.cpp sees a modern GPU and switches on its fast paths: SIMD group matrix multiply, SIMD group reduction, and bfloat 16. The hardware could always do this, the VM just never admitted it. On an M1 Ultra host, the numbers are large. With Tiny Llama, a 1.1 billion parameter model, prompt processing got 11 times faster, and token generation just over 16, from about 13 tokens a second to 207. Prompt processing hit 98% of bare metal performance. A bigger Gemma 12 billion model saw a 7 times prompt speedup and 14.5 times on generation. The gains hold as the model grows. Setup is 3 steps. You build the shim dylib from source in the Loom Metal Capability Shim folder. You flip one macOS default that lets the paravirtualized graphics layer report an unrestricted feature level. Then you launch your Inference binary with the library injected through dyld_insert_libraries and the right feature flags. From there, llama.cpp picks the fast kernels on its own. The caveats are real. It depends on private, undocumented Metal implementation details, so a macOS update can quietly break it. It only affects the one process you inject into, and a hardened signed binary can refuse the injection outright. It has been validated narrowly, one M1 Ultra, specific host and guest versions, so other chips need their own testing. And advertising the newest Metal family broke memory residency under MLX, so the shipped profile deliberately caps how far it reaches. So, a small capability shim tells one guest process. The GPU is a modern Apple family with more thread group memory, and that flips on the fast kernels llama.cpp already had. The payoff is 11 to 16 times faster inference inside a macOS VM, near bare metal on prompts, all over Apple's existing paravirtualized path. The catch is fragility, private APIs, one process at a time, tested on one machine. Clever, useful today, and worth pinning your macOS version for. That is today's AI Daily. Subscribe to BirenAI and ship smarter with AI. See you in the next one.